You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone, and thanks for being here today. I'm Kirk Mona, and joining me are Rachel Gimza and Victoria Thompson. We're all naturalists who together have scoured the world for weird and wonderful wonders, just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Welcome to the show, everybody.
Hi.
So excited to be here.
Good to be with you guys.
Oh, it's so
yes,
fun.
indeed. I've got something, I'm excited for this. I'm excited for every week, you guys.
Right.
But,
I'm
this
never
one was
not
really
excited.
fun. I know. We're going to go back in time. My story this week begins in 1986 in the aftermath of the Chernobyl nuclear disaster.
Oh, what fun.
Yeah. When the reactor exploded and released massive amounts of radiation into the surrounding environment, a lot of people expected the area to become a biological wasteland.
Yeah.
And in a lot of ways, it did. I mean, forests died, animals died, the soil became a toxic mess of radioactive isotopes. A lot of nature survived, though. Nature, it turns out, is pretty tough, and it bounced back, and sometimes in unexpected ways.
I mean, that tracks.
A few years after the disaster, researchers surveying the ruined nuclear reactor noticed a dark, soot-like streak was creeping along the walls of the destroyed unit number 4.
Oh.
These streaks weren't ash, they weren't soot, or any other kind of debris. They were spreading, and they were alive.
Oh, it's alive.
It turns out fungi were growing directly on the reactor's highly radioactive surfaces, flourishing in conditions that would kill most known organisms.
Sure.
And this was
Why
the
not?
first hint.
Why not?
Yeah, this was the first hint that something extraordinary was happening. In 1991, a team of scientists isolated several species of fungi from the reactor site, including, you ready for this? Here we go. Cladosporium spherospermum, Cryptococcus neroformans, and Wangiella dermatidis.
Blah, blah.
Fun.
That's my best guess. It's pretty wild that fungus actually could withstand the radiation at Chernobyl, especially so close to the reactor.
Yeah.
But the story is even weirder than that. These fungi weren't just tolerating radiation, they seemed to be actually attracted to it.
Oh.
Tests in the lab showed that these fungus actually grew faster when exposed to radiation than when they were shielded from it. They would orient themselves toward radiation sources the way a plant orients towards sunlight.
Creepy.
And
why not?
Yeah, it was as if the fungus was actually feeding on the radiation. So,
I mean, sure, why not?
what's going on here, right?
Yeah.
Yeah.
Like there's a new superhero origin story.
Right.
Could
Villain
be.
origin story,
That
perhaps.
could be fun.
Well, the reason
I would
I'm
love to
talking about
be
this
Fungus
topic,
Woman.
all right, we can make that happen. We'll get some t-shirts.
Oh, good.
It might actually fit with your red hair, Rachel, because
Ooh.
the reason I'm talking about this week is it is actually related to my topic last week, which was redheads.
Oh.
So there's actually a connection between redheads and radiation-seeking fungus at Chernobyl.
Do
So-
tell.
Okay.
The key to this bizarre behavior lies in melanin, the same pigment that colors human skin, hair, and eyes. These fungi are now known, we have a term for them, they're called radiotrophic fungi, and radiotrophic means they convert radiation into chemical energy for growth. Last week's story was about how melanin can play a role in something other than just coloration, and this week we see yet another example. So it's actually the melanin that is responsible for this being possible.
Yeah.
And researchers discovered that melanin in these fungi undergoes a structural change when exposed to ionizing radiation, and this change increases the efficiency with which the fungi capture and use energy. So in other words, melanin acts like a biological solar panel, but instead of sunlight, it absorbs radiation.
Okay.
I mean,
Which
sunlight
is-
is radiation, but
Yeah. There
Very,
it is.
very well spotted. Yes, indeed it is. We actually call this process radiosynthesis. It's actually conceptually
it.
similar to photosynthesis. Plants use chlorophyll to convert sunlight into chemical energy, and these radiologic fungi appear to use melanin to convert radiation into chemical energy. And the idea that an organism could harness radiation the way plants harness light seems kind of astonishing, but as you just pointed out, in some ways, really, radiation is just another form of light. They found a way to convert a higher energy part of the electromagnetic spectrum, kind of the same way plants do with light. So, in one sense, the only difference between light and gamma rays given off by radioactive particles is the frequency. We can think of gamma rays as the shortest and highest wavelength of light, and gamma rays are what is given off by many forms of radioactivity. So in that sense, it isn't quite as surprising that some form of life has found a way to harness this incredible energy source. It's actually much more energetic than the light that is used for photosynthesis. This also suggests that life can adapt to environments previously considered utterly inhospitable. Life living in extremely inhospitable places is something we've talked about on the show before. Those are extremophiles.
Probably talk about it again.
Yes, extremophiles are endlessly fascinating. I want to take a little bit closer look at these fungi. Radiotrophic fungi weren't just surviving at Chernobyl. They were actually thriving.
Yeah, they
Some
were.
species grew 3 times faster in high radiation environments than they would otherwise. They colonized the reactor walls, the soil, the cooling pipes, even the interior of the sarcophagus that was built to contain the destroyed reactor.
well,
Whoa.
So,
how
I
is
think I
that
kinda
affecting
picture,
the
like-
integrity of the sarcophagus?
That's
Well,
a
I mean,
great
it's-
question.
It's concrete. I will say this kind of as an aside. The original sarcophagus, was built very quickly, and it has had showing signs of its age. And they did just within the last couple of years finish a new containment facility around the entire building now. So it's
good.
called. I think it's called just the new containment, basically. But
Well,
it's
that's
there is
boring.
now another layer around the outside because the original one, it's getting old.
We've got to work on that.
Horrifying.
we need a
okay.
little more time for
Lucky
things to
ducks.
cool down around there.
Woo.
So the presence of these fungi has really raised many questions. Like, one was, how long have fungi possessed this ability? Like, is this a recent adaptation? Or is this an ancient survival mechanism from a time in the deep past when Earth was regularly bombarded with far more cosmic radiation? Like the early days of the Earth was just bathed in radiation from space and also radiation from Earth because there was a lot more radioactive material on the Earth. Even just because, like, think about things like uranium.
It decays.
The half-life of that, like, it had not, there's less around. A lot of it has radiated away since the beginning of the Earth. So it is possible that these were things that this type of fungi was much more common, like in the early days of the Earth than it is now when we just don't have that much concentrated radiation around. So these questions kind of transformed radiotrophic fungi from a biological curiosity into a subject of intense scientific interest. And we're still studying them today, trying to learn more about how they work, but also how we might actually put them to work. So one of the most exciting implications
That's
of radiotrophic fungi lies in space exploration. Because space is saturated with radiation, as we said, cosmic rays, solar particles, high energy photons, and all these things pose a very serious risk to astronauts and to equipment once you get past the magnetic field of the Earth that protects us.
Right.
Shielding against radiation is one of the biggest challenges in designing long-term missions to the moon, Mars, or beyond. The Artemis human mission to the moon is launching any day now as we record this, so that's going to be really exciting. This isn't theoretical. Humans are leaving Earth and exploring our solar system. And an interesting possibility is that this fungus could actually be used to protect us as a type of shield as we venture out past the protection of Earth. Experiments conducted on the International Space Station have shown that radiotrophic fungi can grow in microgravity and may even provide radiation protection. A thin layer of Cladosporium sphaerospherum
Okay.
grown aboard the International Space Station, reduced radiation levels beneath it. It wasn't a total blocking. They think it could theoretically block a little bit over 4% of the radiation, but that was enough that scientists are considering how it could be part of like a series of barriers to protect astronauts. And they're
Yeah.
also looking at how it
Yeah.
could be used on Mars. You could basically grow a protective shield once you got there. Taking things with you is quite expensive. So if you could mix it in with some of the Martian regolith and like in soil and basically create your own protective barrier,
That'd
why
be
not?
huge.
Right?
Yeah.
But
Yeah. I mean, you can
Important
imagine a Mars
question.
habitat.
how does it taste?
What's that?
Ooh.
No, yeah, I don't know. It's I'm not going to go licking any walls to find out.
I mean,
but it-
from my understanding, for like things that are potentially toxic, like that, probably sweet.
Oh, great.
I mean, lead
like-
is sweet, apparently.
Yeah, a lot of things that
yeah,
are
but-
toxic taste really bad to humans. Like
Yeah.
we've evolved the ability to taste things that are toxic to us. It's part of how we survive.
That yeah.
Things that are bitter, basically. You know, it's why humans don't like the bitter things that taste bitter in general.
Yeah,
It's
that's fair.
you know, there's acquired taste for certain things because a lot of those are mostly alkali compounds, which often are toxic to humans. But we're getting
Anyway.
away from our topic here.
Yeah.
I'll say, imagine, like a Mars habitat lined with a living fungal layer that absorbs cosmic radiation, repairs itself when damaged, and grows thicker over time. It sounds like science fiction, but the early data suggests that it could actually be possible. And there are, of course, possible issues of, not minor issue, of contaminating an entire planet with a new life form.
Right.
And that alone, right there, may mean that we just can't use it on Mars. I think the risk of it escaping and, covering the whole planet, that's probably
not small.
not a great thing for us to be doing. But speaking of life on other planets, radiotrophic fungi also expand our imagination about what life might look like elsewhere in the universe or the
Yeah.
solar system. If organisms on Earth can use radiation as an energy source, then perhaps life on other worlds, especially those with high radiation environments, could also evolve similar strategies. Europa,
Sure.
Jupiter's icy moon,
Yeah.
is bombarded by intense radiation from Jupiter's magnetosphere. The surface seems inhospitable, but beneath the ice lies a vast ocean. So, could radiotrophic organisms exist in the ice layer? I mean, and maybe they're going to use radiation from above to power life below. Maybe. We don't know yet. We got to go check it out and find out. There's other places too. Enceladus, Titan, and maybe even Mars itself present similar possibilities. So basically, we got to go. We got to either go ourselves or send some probes and find out what could possibly be living there. Radiotrophic fungi remind us that life is not limited to the narrow band of conditions we often assume are necessary. Life is highly opportunistic, adaptable, and endlessly inventive, and thankfully, because otherwise what would we talk about on this show? But most certainly, it won't fit into our little boxes, right?
Yeah.
Not
and
at
our
all.
definitions.
You might say life finds a way.
Finds a way.
Finds a way. That's right. So despite decades of research here on Earth, radiotrophic fungi still hold many secrets and are something we're still studying. Scientists don't fully understand the biochemical pathways behind radiosynthesis as well as we do compared to something like photosynthesis. So it's still being studied. We don't know how efficient the process is or whether it could be enhanced to make it even more useful. They don't know whether fungi evolved this ability specifically for radiation, or whether melanin's role is just a lucky accident of evolution, as so commonly happens. What we do know about these organisms challenges our assumptions about energy, survival, and the boundaries of life. So Chernobyl, while it was one of the darkest moments of modern human history, it did also reveal a form of life that may help us explore other planets, protect astronauts, and rethink the limits of biology. So kind of a silver lining there, or I guess a black lining since it's a black fungus.
Yeah.
As scientists continue to study them, one thing becomes clear. The universe may be far more hospitable to life than we ever imagined. And it just might be that we're imagining the wrong kind of life. My sources this week were Science News, the journal Mycological Research, and then just some general info from good old Wikipedia.
Awesome. Thanks, Kirk.
Yeah. Some little something to think about there.
Yeah.
We're going to take a break, and when we come back, it'll be time to hear from Rachel.
Woo. Welcome back, everyone. As Victoria can attest, I'm sure, having gone through medical school and nursing school.
I did not go through medical school. But
No,
yes,
but you did go
nursing
through
school.
nursing school. Medicine is always trying to beat the germs. Okay?
Yes.
We're in a constant arms race with viruses and bacteria, both us and the viruses and the bacteria are all trying to survive and spread. Yeah.
Yep, what doesn't kill us mutates and tries again.
Exactly. You have a patch of that.
I do. My backpack at work literally says that on it.
So we've discussed on the show a few times a few ways that we as humans used to deal with illnesses and infections and the breakthroughs that we've made, especially in the last century. There's been some really strong, amazing breakthroughs. However, as we advance, so do the viruses and bacteria. They are more and more becoming resistant to antibiotics. Not to say
Scary
that
stuff.
that antibiotics don't work every single time, because if you get prescribed antibiotics, please take them
Take all of them.
Take them and take them until you are told to stop. Take them all in the prescribed dose.
Thank you for that PSA.
Thank you. But there are a few bacteria, especially, that are resistant to those antibiotics. One of the more serious, I would say, infections is MRSA.
Yeah, I saw that coming.
Yeah, MRSA, or methicillin-resistant Staphylococcus aureus, is an infection caused by the Staphylococcus bacteria. Now that's relatively, it's also known as staph infection. You probably have heard, at least in some medical shows and things. MRSA is the infection, the bacteria that is resistant to antibiotics. So MRSA generally is some sort of infection. It's where the site of the infection turns red, it swells, it can become painful, and your body's trying to fight that off. Now, often what will end up happening, or what can happen, is you can develop pneumonia. It can get into your bloodstream, which means you're getting a bloodstream infection.
That's not good.
No, the sad moment. That actually is something similar happened to my mom, which is why she's no longer with us. So please be careful. It can also lead to things like sepsis, which is our body trying to get rid of an infection. It's the most extreme response that we have in our immune system. And then if it's untreated, it can cause you to die because it's an infection and it's spreading. So overall, not a good time. So science has been trying really hard to try to find a way to combat this. Just because it's resistant to a lot of the medicines that we have today. That being said, something interesting has happened recently. And when I say recently, I mean that it has, it's in the last 5-6 years. This is in 2020. So.
Okay.
All right. So this is still relatively recent. I understand why
more than half a decade ago, right? Yeah.
Well, I mean,
geologically recent.
Relatively. Now, that being said, there actually seems to be a medicine or a treatment for even MRSA that has some pretty old origins.
I have a guess what you're going to talk about, Rachel.
I think you would do. So, way back in medieval times, there's this beautiful 10th century medical text called Bald's Leechbook. Okay? And in it has all of the ways that we used to treat different things. And one of the treatments in this particular book, and again, had medicine, salves, treatments. This is also the time where leeches were a popular way to get rid of things.
Mhm.
So that's the time. But it also suggests using something called Bald's eye salve. Okay.
Mhm.
Now, what is Bald's eye salve? Now, it is a mixture of garlic, onion, or some sort of alum,
Okay,
wine.
this is not where I thought you were going.
Oh, okay. It's a mixture of garlic, onion, wine, and just a little bit of cow bile.
Oh,
Okay?
Yum.
Now, right,
delicious.
delicious. But here's the thing. You take all of that group and you have to crush them together, mix it together, and it has to be left to stand for 9 days. Okay?
Okay.
Now, this was originally a treatment for like a cyst or a lump within the eye. That's what they called it. You would have it within a brass or bronze container for 9 days, and then you were able to take it through a cloth and clarify it. So you would put water
Strain
or
it.
something through it, strain it. Okay. And then you would apply that to the area and it would seem to work. It would get rid of the infection or whatever was the issue. Here's the thing. Some scientists were like, what if it works?
I mean, garlic does have antimicrobial propries, so I mean, it seems worth a shot, right?
So yeah, so they haven't demonstrated like how safe it is, but so it has not been tested in humans. However, they tried using it, and it seemed to actually be relatively good for microbes that are have antibiotic resistance.
Wild.
So there is some, like, it could be effective at maintaining things like, or like combating things like MRSA. So what happens is, and it doesn't happen like, it has to happen in that particular like way. When you're making the recipe, it has to be in with all of those ingredients. Not one of those ingredients has a better aspect. It has to be the combined, and it's the interactions of all of those ingredients being left in a bronze or brass space for 9 days.
Interesting.
And somehow,
so they tested like all the different variations of that, but only
Leave
that
out the
version
onion,
worked.
and that I guess works the best.
Yeah.
Whatever.
And
okay.
that particular bit works the best. And what happens is it is able to like combat the biofilm infection. So like bacteria that band together to make like a barrier.
Biofilms are terrible.
They are. And
your teeth are covered in them.
Yeah. So it's able to like hit the biofilm and like break it down so that way antibiotics and things can work further. It's really fascinating. So these scientists were really just curious. Like, this is an old method of treating medicine or treating injuries and like infections. So like, why not try it out, you know?
There's something to it, yeah.
Yeah, so they were like, I wonder how effective it would be against MRSA, and it seems to be like it is active against any sort of. It could be a very possible method for us to go forward with not necessarily a cure, but another method to fight MRSA infections.
Another weapon in the arsenal, as they say.
Exactly.
Have they tested this in any animals, or is this all just in petri dishes so far?
So far it seems to just be in like petri dishes. I think maybe they started treating it with mice. It's definitely not any sort of. It's not in humans or ready for humans or anything like that. But
I mean, other than all those medieval humans, as you pointed out.
Right. Other than that, yes.
Some of the science memes where they're like, they'll have like a petri dish and they'll kind of show, they're like, hey, bleach kills cancer in a petri dish.
Yeah.
Doesn't mean you can inject yourself with bleach.
Exactly.
Right?
Some people tried.
Yep.
Yeah. So it seemed to be like, it was just interesting to see that people were using very ancient technology and ancient recipes and still finding them somewhat effective to this day. It's obviously part of that might have to do with the fact that we haven't used that particular method in a long time. So the memory of the bacteria for that probably doesn't exist anymore. So
it probably wasn't widespread enough to
exactly
make an impact too.
Mm-hmm.
Also, it's just fascinating that the people who came up with that recipe originally were able to develop it. Like
apparently
so
bald.
Bald.
Well, and it was probably, a heal-all. Just get a bunch of herbs and throw them in. And, that was the early days of science and medicine, really, where it's like you're just throwing stuff at the wall and you go, you know what, this person didn't die. I'll try that again,
Yeah.
And over time, the things that work, we end up calling them medicine.
Mm-hmm.
And it works out.
Yeah. And I will say, like, this particular, it shows promise. It's not necessarily like, I'm not saying go make this and you'll be fine against MRSA. No. That's not how this works.
Don't.
Please don't.
Please do not.
Please don't. Take your medicine. But it does seem to be at least some sort of promise to add to our arsenal.
Some avenues of exploration.
So it'd be really fun. So I just learned about that and I decided to talk about it a little bit. So my sources this week, there's an article in Smithsonian Magazine by Alex Fox. This medieval potion kills stubborn bacteria. And it was more than just MRSA, but that was like the most severe one that they were talking about. I also got a little bit of information about MRSA infection by the CDC. The paper itself was published in the National Library of Medicine. The paper is called The Safety Profile of Bald's Eye Salve for the Treatment of Bacterial Infections. And it's by Blessing Anoye et al. They all did.
I bet it
really
smells
great.
really bad, though.
Oh, I'm sure it smells awful. Well, the bile, I think, would get me. Yeah. Mm-hmm. And then some basic knowledge of how the recipe works in Wikipedia. So that is what I've got for you all this week.
Cool, thanks.
Yeah.
Cool.
We're going to take a quick break, and when we return, it'll be Victoria.
This week's episode is brought to you by the Society of Strange. That's what we call our patrons over at patreon.com/strangebynature. Society members directly support the show they love, and depending on their level of support, get fun perks such as bonus content on select shows, insider photos, water bottle stickers, and here's a big one, every level of support gets every episode 100% ad-free. Come join the other lovers of the show, help keep this strange show going, and get those ad-free episodes. We'll see you all over at patreon.com/strangebynature.
I am always fascinated by creatures that manage not only to survive, but thrive in cities and other areas heavily used by humans. There are some species that are actually now evolved to be dependent on humans, at least in part of their range. So house mice, cockroaches, bed bugs. Which, like, for example, can survive in Arctic areas because they shelter in human buildings.
Oh, interesting. Yeah.
Yeah. And of course, there are the more numerous species that don't depend on humans, but are able to tolerate or exploit being around them, like the famous pizza rat, raccoons breaking into garbage cans, crows eating roadkill.
Yeah.
Squirrels and pigeons munching on your fallen Doritos.
It's really funny, too, because there's actually a distinct difference between, like, urban raccoons and rural raccoons.
Yeah.
It's fascinating. Anyway, go on.
Also, the amazingly bold rabbits that inhabit my backyard in Minneapolis.
Yup.
One of them a couple summers ago decided to build her nest in a large planter that we had up on our back deck.
Yup.
A fact I discovered when I went to water the basil plants, and
Oh,
four
no.
tiny baby bunnies emerged from the dirt.
Oh. Yup. I had that
Problematic.
moment.
Lay your
in,
babies there.
I had that moment in a raised bed garden myself, and I went to go check. And I'm like, no, we don't want to. Oh, there's already babies there. Great. Okay.
Yeah.
These species are highly adaptable and obviously not highly sensitive to things like human presence and the noises that we make. And of course, there are many hardy plants that have adapted to city life as well. Dandelions, the tree of heaven, which is a notoriously weedy species.
Oh, yeah.
Just a few examples. I'm sure you can think of more that grow near you, dear listeners. These plants are hardy to pollution and often do well in disturbed soils.
Buckthorn.
But
Garlic mustard.
buckthorn, yep. Today, I am going to talk about another organism that is highly adapted to urban life, but is a little less well known. Also, it is fairly metal. Today I'm talking about a mushroom. Its
Nice.
scientific name is Agaricus bitorquis. It is a mushroom-looking mushroom.
Amazing. Love it.
Fair enough.
Similar in appearance to the common white button mushroom that you find at your local supermarket. In fact, it's in the same genus.
Okay.
However, the stem is noticeably thicker, wider, and tougher than a button mushroom.
Okay.
And this tough stem is an important adaptation for its lifestyle because I am now going to tell you the common name of this fungus, which is the pavement mushroom.
Amazing.
Oh, nice.
I'm in. I love it. I love
Yes.
it.
It is
Oh my
commonly
God.
found in cities and hard-packed soils, such as next to roads, in ditches, and on heavily traveled park paths.
This
But it
is so fun.
yeah, I guess you could say notorious for being found pushing up through sidewalk cracks.
Yeah.
You can even find pictures of them apparently pushing up through unbroken asphalt. Although
Wow.
likely this is like a quickly or cheaply laid asphalt patch, most likely or it has cracks on the underside that the
Yeah.
mushroom was able to
Gotcha.
exploit. The reason that these mushrooms can exert such force as to push through pavement is the same reason, really, that mushrooms in general can grow so quickly that they sprout up overnight in some cases.
Yeah.
That is hydraulic pressure.
Mm.
Huh.
Yeah. Mushroom fruiting bodies, that is what we call mushrooms, are mostly water, and they have mechanisms in place to be able to quickly absorb large quantities of water from the soil into their cells.
I guess
And
that makes sense.
it seems, from what I was able to determine while researching this, it sounds like, in general, like most of the cells are already largely in place before the mushroom sprouts, if you will. And then they
Yeah,
quickly
interesting.
pump water. The mushroom quickly pumps water in from the mycelium to inflate the cells that are already there. So they
Okay.
just
Cool.
get bigger. And this is faster than the different and slower process of cell division and multiplication, which is how we normally
Right.
think of things growing.
Mm-hmm.
So they're kind of just inflating.
Yeah, they're
Yeah.
inflating, pretty much.
Like a balloon.
a water balloon.
Oh, man.
Less fun to throw at people, probably.
Yes.
Don't throw water balloons at me. You can throw
Well,
mushrooms,
I
though.
can't make any promises, Rachel.
You might like to have these mushrooms because they actually
Yeah.
are edible
Ooh.
and
Yeah.
reportedly quite tasty. Of course, we do not recommend foraging mushrooms unless you are an expert because of the high risk of poisoning if you don't know what you're
Yeah.
doing.
Yep. As we've discussed on this show several times.
Indeed. In addition, mushrooms in general tend to take up and bioaccumulate heavy metals. So
There it is.
foraging from urban environments is
Feels
extra
like
risky.
a bad idea.
Let's take it from this road that, leaded gasoline was deposited along for
Yeah, don't do that.
decades.
Yep.
No.
But if you are interested in tasting the pavement mushroom, rather than harvesting it from your local pavement, you can buy home cultivation kits. They're not one of the more common ones, but you can. I looked around. You can find them.
Okay.
They're called apparently Torques. That's like the nickname.
That's fun.
Yeah. Bill Torquist. By Torquist, excuse me. It's from the species name.
Okay.
Yeah, I don't have a whole lot more about the pavement mushroom. I just thought it was super cool and very, very hardcore that this mushroom just pushes its way through asphalt.
That's
It fully went like, it fully is like, no, everybody else is too soft. I'm going through concrete.
Yeah.
I think it's usually more asphalt that they can push through than actual concrete.
Yeah, they can go through cracks in the concrete.
Yeah.
Asphalt's a lot softer than concrete.
It is much softer. If you've ever gone for a run, you know.
Yeah.
That's the case.
Yeah, I suppose, yeah. The few times I have run.
My sources this week got some information from mushroomexpert.com and ediblewildfood.com, a little bit from Wikipedia as well, and then, various mushroom cultivation websites.
That's awesome. Thank you, Victoria.
Yeah.
Very cool.
And I think that wraps up our show.
Yeah.
Sure does. It was
Look
a
at
fun
us
one.
go.
We went from fungus to fungus.
Yeah.
Yep. Fungus to medieval potion to fungus.
If only there'd been some fungus in that potion.
I know. I
fungus
thought about that.
trifecta.
I guess I just missed the memo that we were doing fungus.
Yeah. Get with the program.
Oh, another time.
All right.
All right.
Bye,
Thanks,
everyone.
y'all. Bye.
Bye-bye.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all our listeners. If you would be so kind as to leave us a 5-star rating and review wherever you get your podcasts, that would be great. It lets other lovers of the strange discover the show. You can reach us by searching for Strange by Nature Podcast on Instagram, Facebook, and Blue Sky. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can check out our website, strangebynaturepodcast.com, and you can support the show and get ad-free episodes at patreon.com/strangebynature. Until next week, get outside, stay curious, and embrace the strange.